Here's a problem you can try if you're ready, or you can just watch on and see how Mrs. Brown does it. The average IQ score for adults is 100 with a standard deviation of 15. And that's actually true. Assume the distribution of IQ scores is approximately normal. And that's also something that is true. We assume that. Find the percentage of adults who have an IQ score less than 90. So number one, IQ less than 90. So the first thing I'm thinking is, well, what does my distribution look like? And you should always draw yourself a distribution first. Try to make it look smooth. Mark in your 0. And in this case, we know that's 100, and we can also put the 0 down below. So the 100 is my data value, so that's my x's. And the 0 is my z value that corresponds with it. So if I plug in this 100 and into my z-score formula, I should get 0. That's what we want to see. And then there's 1, 2, 3 standard deviations. 1, 2, 3 standard deviations. So 15, that'll put this at 115, 130, 145, 1, 2, and 3, and subtract off 15, that'll give me 85, 70, and 55, -3, -2, -1, and 0. So we can see if 100 is our middle, that most of our population is going to have an intelligence quotient, IQ score, between 55 and 145. That'll be normal for most people. We know that 68% approximately will be between 85 and 115. 95% of our population is going to be between 70 and 130, and almost all between 55 and 145. 145 is extremely smart, 100 is average, and 55 is intellectually disabled. Okay, we're looking at someone with an IQ of 90, and I can see they're in here, right about here. So I'll put a little mark. That's about 90. So I want to find what is the z-score first. So we will do z equals x minus mu over sigma. 90 minus 100 over 15. 90 minus 100 divided by 15. And I get negative 2/3 essentially. 0.67. Remember, we like to round it to 2 decimal places. And then I want to know who have an IQ score less than 90. So I'm going to draw just a quick distribution. Here's my 0. Here's my negative 0.67. And I want less than that. I want everyone who's in this region that I've shaded. Well, I can't get that from my chart because the chart just gives me 0 to a certain z-score. So what I have to do is think about first the symmetry. Think about, well, what if you flipped it over to the other side? Then I could just look up a 0.67 and it would give me a z-score that, or it would give me an area for the region I'm interested in. But it's going to give me this region right here. And that's not the region I'm after. But I can remember this whole side from 0 all the way left is 0.5. And so if I'm getting a part that I don't want, I can take that away from the 0.5 and be left with the part that I do want. So that's exactly what I'm going to do. So I'll look up the 0.67 on my table. 0.6, I see it right here, all the way over to 7, and that's going to be right here. 0.6 plus 0.07 will give me 0.67, so it's 0.2486. So this region here, 0.2486. And I really, really want to know this shaded region, not the region that I got. So I take 0.5, which is the whole left-hand side, and take away the part I don't want to get the part that I do want. So 0.5 minus 0.2486. And I get 0.2514. And that will be for that shaded region, 0.2514. So we know then that 25.14% of people have 90 or less IQ.